Okay, so now we're going to do a video on distance time graphs, okay? Kind of put together a lot of things we've been working on. All right, the first thing you want to notice about a distance time graph is that the time is going to be plotted on the x-axis, and it may be hours, seconds, it'll just be whatever. Okay, they should put it there what it is, or it'll be obvious. Then they'll have distance on the y-axis, okay? Distance is plotted. Again, distance can be meters, yards, whatever, miles, whatever. Okay, then couple things to notice is that if you have a straight line like that graphed on a distance time graph, that means that as time is increasing, you're still the same distance. Like a lot of times the distance will be distance from home or distance from school. So if this is like 1 mile, supposing this is like 1, and that's all in miles, then you're 1 mile, all the time you're at school, if you're a mile away from school, that's a graph of you being at school, because you're still a mile away from home and time is going by. You haven't moved in a sense. Okay, so as time is increasing, but the object's distance, or the person, whoever this is describing, the distance does not change. It's an at rest. In a sense, you're at rest, or you're not moving further from the original point. You could be running in circles. You could also describe if this is your house, if this is your little house, and you have a dog maybe that's running around in circles around your house. They're the same distance from your house every time, if it's a perfect circle and all that. But time goes on, but he's still the same distance from home. So in a sense, the dog is really not at rest. But in general, besides a few exceptions, this is pretty much a description of something just sitting there. Like if you're waiting at the bus stop, this is you waiting at the bus stop. You haven't moved. You're the same distance from home that you were, and time is going on. Okay. Another type of things, we talked about this a little bit, but you have, like for example, if you have just a regular line going up at a constant rate, that's as time increases, the distance is increasing at a constant rate. So you're going along like a steady speed, a constant speed. Now, if you're a little bit steeper, the steeper line means you're going faster because you're traveling a lot more distance in a little bit of time. Okay, another graph is this one, where the object is actually accelerating. It's going faster and faster. See here, over time, it started out going a little bit slow, getting a little bit of distance, but not much, but time was going by. And then it sped up. It's getting a lot of distance and a little bit of time. Okay? So those are some basic type of graphs you're going to see. All right. So now, let's go through some examples. Okay. Oh, a lot of that has been already. Okay, we'll just go through that. Okay, so first example. Here's your graph to the bus stop. And you can go ahead and plot this if you like. If you have graph paper, you might want to get some graph paper and graph it, or just try to be as careful as you can graphing it. But let's look at the graph first. You're going to the bus stop. This is the time in seconds that you take to go to the bus stop. It's in tens, 10, 20, 30. And the distance in meters from home. So here you're at home, 0. Your 0 distance from home means you're at home. And then you go 20, 40, 60, etc. Okay. So you have a line that you're going up a hill. You're not going up a hill. You're going from 0 to 100 meters, and then you had to go back closer to home. You're going closer to home, it looks like, and then you're going further to the bus stop. Okay. So first of all, this is not a description of you're not walking up a hill, and then down a hill, and then up a hill. First, when you look at it, you think, oh, that's what I'm doing, walking up a hill, going down a hill. But you must be careful with what everything means. Remember, this is time, and this is distance away from home. Okay, so in 10 seconds, you're about 20 meters away from home. Whether it's a hill, downhill, uphill, flat, doesn't matter. There's no way we'd know offhand. So always want to start where you start. You start at the 0, 0. You start at home. You walked about 100 meters in about 50 seconds. Okay, that's one thing you can kind of notice. Then perhaps you forgot your math homework or forgot something, and you had to go back home because now you're getting closer to home. Or maybe you went to go pick up your friend who said, oh, don't forget to come knock at my door on your way to the stop. Okay, whatever it is. Okay, I'm going to try to write that in. But perhaps you forgot something or whatever, so you ran back toward home. You're going a little faster. If you notice, you're going a little faster because you're going about 60 meters here because you went down to 40 in about 20 seconds. So that's something you can count. I didn't go that fast walking to the bus stop. So, but one thing I thought of, so you walked faster toward home, but your mom, however, saw that you forgot it, so she met you. She started walking to meet you. That's why you didn't have to go all the way home, because somebody or something, or maybe you went to the friend's house, whatever, and they met you, and then you realized, oh, I better run, because see how this is steeper than that? So you ran, then you ran to the bus stop, because you thought you might be late. And you ran 120, this is 120 meters, from 40 to 160 is 120 meters, if you notice, in only 10, 20, 30 seconds. So you see, oh, that was much faster than originally. So see how rich this is, see how much you can tell about what's going on. You may have a different story about maybe something you forgot or something you went and picked up, maybe you dropped something. Okay, so another example is jogging. Okay, so we're going to describe here, here's your graph, it's the time and distance from home, and there's your jog. So there's lots of different ways you could think of this, but one way is, okay, you started at home, and supposing from here to here you're jogging, you're going pretty fast, you're jogging regularly. Then perhaps right here you might have met up with a friend who's jogging not quite as fast, or maybe they want to walk, so maybe you decide to walk and talk to your friend. You're still away from home, and then you've gone as far as you usually go, and then you say goodbye to your friend, or maybe you and your friend ran back to your house to get some lemonade or something. Okay, that would be one way to describe what happened. It's not you went up a really steep hill and then a not so steep hill and then you ran down the hill. It's not that because of how it's graphed. It's time and distance. Okay, other graphs we can talk about. If you look at this, you're going to think distance from home again and time. You might think this is going to be, it could be walking up and down a hill at a steady rate away from home. Or it could just be walking on a flat surface. I just put that in just to help you see that. This could be walking up and down a hill. As long as you're steady, as long as the time that went by, you kept going the same amount of distance. That would be one description perhaps. Now if you have this one, this could mean that you walked at a steady speed and then you turned back home. It's not up and down a hill again. It means you walked away from home, then you turned around and walked back at the same rate that you walked there. Maybe you're going to your friend's house and coming back. This one could be you ran to your friend's house and then you immediately walked back home. Maybe your friend wasn't there. Here you walked to your friend's house and then you ran home. Now if you were to stay at your friend's house, how do we do that? We could make that to be, if you ran to your friend's house, stayed there, had lunch with them, and then you ran back home, or if you walked back home, okay, that would be, that distance would be you're staying at the same place, that you're at rest, you're just staying there, and your time's going by, but you're still in the same place, same distance away from home. Okay, one more. All right, so now we have some other ones. Again, same thing, distance from home and time. Now this one, here's a question. Which one of these graphs shows a person walked up a hill near his house, walked across the top of the hill, and then ran down to the other side? Well, I think you know it's not going to be that one because that's pretty obvious. Okay, but this is, you're right, this is the one that it is. It's this one right here. Now why is that true? Well, if you walk up a hill, you're going pretty slow. It's a pretty, even line, almost flat, but you're going a lot of times going by and you're barely getting up the hill. Then you walked across the top of the hill. Well, that would probably be pretty easy. Maybe you ran across it. And then you ran down the other side, but you're still away from home. You see, you're still a lot away from home. If you ran down, if you just walked across and walked back again, then you'd go this way if you walked on the same side if you ran down the same side you walked up. Here we can describe this as kind of like what we did before. Say you're starting out from home, you're taking a nice little walk away from home. Maybe you went to your friend's house, then you stopped at your friend's house and had some time with your friend, and then you ran back home or ran with your friend back home or something. Okay, I hope this makes things clear. We're going to do an activity in class that'll help you put a lot of these together and you'll be able to mix and match them.